In this video, I will go over the solutions of the equations which we are getting from taking partial derivatives of this equation. P depends on two variables, A and P. So we created two equations by differentiating the original equation with respect to A and with respect to P. And I will call those two equations 1 and 2. The question is, how did they receive those three pairs of solutions? Let's go over this slowly. The first equation looks easier, so I will start with the first one. The first equation is 4p minus 1 over 5 p times a equals to 0. If you're not comfortable with working with different letters like a and p, you can always set a to be x and p to be y, and then work with those variables instead. Do not recommend to do that because in your future career and future classes you might have many different variables. The earlier you feel comfortable using different letters, the better. I don't like working with the fractions, so I will multiply both sides by 5, and I will get 20p minus p times a equals to 0. Now I will factor out p. It gives me 20 minus a equals to 0. The product gives me 0, so each factor can be set to 0. P equals 0 gives me the first solution, and a equals 20 gives me the second one. The thing is, when p is 0, the whole product is 0 regardless of a. So what is a then? Seems like a can be anything. Same with the second pair. When a is 20, the product gives me 0 regardless of what p is. So what the p is then? And our job is to find those pairs of solutions. To find the second half of the solution, I will take whatever we found, the information we got from the first equation, and I'm gonna plug it to the second equation, one by one. So, step 2, I will look into, or I will even write down for you, plug into 2. Now, since first I'm plugging, I will even write down p equals 0. I'm plugging this. Then I'm not touching a and anything that has a as the factor. 4a plus 120 minus 0, because p is 0, minus 1 over 10 a squared equals to 0. So now since p is gone because p is 0, this is a quadratic equation, which is basically a parabola. And there are many ways to find solutions of this quadratic equation. Interesting to point out, because of the square, I'm expecting to have two solutions. They might be the same, but maybe different. So it might be a1 and a2. I don't like working with fractions again, so I will multiply everything by 10 to get rid of the 1 over 10s. Also, I want the leading term a squared to be at the beginning, so I will multiply everything by negative 10. You don't have to do that, but to match the formula of quadratic equations is just convenient. If I multiply everything by negative 10, it will give me negative 40a minus 12 hundredths plus a squared equals to 0. Looks much better. Rearranging terms gives me a squared minus 40a plus 12 hundredths equals to 0. Now, many ways to solve this equation. If you don't know how to factor out, always, if you feel like you're stuck, always use quadratic formula, which is with x, if you remember, minus b plus minus square root b squared minus 4ac all over 2a. In this case, be careful, your a here is not the same as a over here, so rename everything nicely to make sure you don't mess up. But instead, I will factor out. So that's just a reminder, and make sure you don't mess up with letters. Instead, I know the solutions will be a minus 60 times a minus, or actually plus 20 equals to 0. You can multiply those out to check that I'm right. And how did I do that? I actually used a Vieta theorem. If you know what it is, then that's how I do it. It's just faster this way. I got used to it. Now, with those two solutions, I have a equals 60 and a equals negative 20. But what does it mean? So it's a1 and a2. Just like I told you, we have two solutions here. Remember that originally we had p equals to 0. So we're gonna have two couples here. Let me put it in two different colors. In purple, I will have a equals 60. I'll put a to be the first one in the couple because a goes first. A is like my input and p is my output, like x and y. So a equals 60 and p is 0. That's my first couple. Basically, you can read it out loud this way. When p was 0, a is 60. The second one will be a is negative 20 and then p is 0. That's the second couple. We're almost done. Let's see that we are right or not. 60, 0 minus 20, 0. Here they are, 60, 0 minus 20, 0. Those solutions were found by plugging p equals 0 into second equation. So this piece done. Now we just need to do the second part. Let's plug a equals 20 into the second equation. If you do that, then you should get the last piece, 20 and 4. So let's do again. Plug a equals 20 into second equation. Just carefully plug it in. And if you don't mess up, you will get a solution. A equals 20. And then calculate carefully. So this a over here is 20. And this will be 20 squared. And everything is fine. Then just solve for p. It's not even quadratic equation anymore. And apparently p should be 4. Check yourself if that's true. And that's how we got 3 pairs of solutions. 60, 0, minus 20, 0, 20, and 4. Hope it was helpful. Practice a little bit more. And don't be afraid to play with numbers. You got some solution, plug it somewhere else and see what's going to happen. Usually that's how you find all the possible solutions. In this case, we have 3 couples.